I have a nice data set here that came from a UAV that'll allow me to demonstrate how to create a bare earth digital terrain model. Switch back to top-down view. What I'd like to do is focus in on this part of the point cloud, because what you'll see is we've got a combination of bare ground, but we've also got some trees here, and the trees, if they were part of that surface, would generate an inaccurate model of what the real ground looks like. So we'll use some tools that allow us to filter through those trees. Just so that I can focus in this area, I'm going to set up a rectangular clip. And there we're focused right in. Now, what we need to do is set up a grid now, because what we're going to be doing is kind of an elevation sampling process, and we're going to be using the grid as the guideline to that sampling process. And so I can go to the grid settings here by right-clicking on this tool here, go into the settings. So I can check this to turn on my grid, and here I can set what dimensions I'd like to use for my grid. So it's going to be a 5x5 grid, and I like to check on display beyond limits just in case there are limits in effect. As soon as I say OK there, I can see that the grid is displayed. If there is a reason that I wanted to realign that grid, there's a handy tool in here. I can go to the orientation section of the point cloud ribbon and tell it that I want to define my UCS by 2 points. So 2 clicks, and so notice how the grid realigns itself. That might be useful if you wanted your sampling to proceed down a road that wasn't going due north or due east. I will reset my view back to the original cardinal orientation. Okay, now that we've got the grid set up, we're going to use the Points on Grid tool to do this elevation sampling operation. I'll open this tool up. First thing that you want to do in this tool is define a fence. So it can be a rectangle fence, it can be a polygon fence, it can be a circle fence. That will limit your elevation sampling. So I'll just define a rectangle here. Just quickly draw that, and now we've subdivided things. Now, what's going to happen right now is we've got things configured so that it will search for points that represent ground in a 1 meter radius around the intersection points of each of these grid lines. I'll have a look at the other settings here. The origin of the grid is going to be at 0, 0, and 0. You can change that if you want to. The grid display read from the CAD setting is already 5 meters. Okay, so let's just have a look at these options here. So we've got the option of doing a search around each one of those grid points for either the closest point, or the closest point cloud point, the highest point cloud point, the lowest point cloud point, or with ground, it has an algorithm where it'll do its best calculation on what elevation represents the ground in that 1 meter radius, and it'll create a point right at the intersection of the 2 grid lines. So I'll show you the most common, the lowest search, and preview just allows me to get the program to look through the data set, and here it's giving me a little preview of what points would be created if I hit the Place Points button. So here it's searched for the lowest points. Now you'll see a subtle difference if I switch over to the highest point. So right now, hopefully, under the trees that we've got here, it has picked a point on the ground to represent what the bare earth ground would look like. If I switch to highest now and go for preview, it's much more likely that it's going to pick points at the tops of the trees. And with highest, I'm probably not going to get something that's representative of the bare ground. Ground, on the other hand, you'll see a slightly different result. I'm going to hit preview. So it's going to search for an elevation that represents ground as best it can, and it's going to place the point node right at the intersection of the grid. So the idea is you want to play around with your radius and your spacing until you've got something that looks fairly realistic, and then when you're done, you're going to hit Place Points, and what that's going to do is it's going to draw a real CAD node on your current layer. I'll turn those points into points that represent the ground. Okay, so now they are created. And now the next step in this process is you want to do a bit of an inspection to make sure that the algorithm was accurate and that it didn't accidentally pick any high points in your surface. As I turn it on the side, I'm holding the control button and my left mouse in order to spin things around. It looks to me like it's pretty accurate. Here, I'll turn off the grid because it's causing me a bit of confusion. Looks like it's accurately filtered through most of the trees and so forth. Okay, and then when the inspection process is over, now you've populated your drawing with enough point nodes to make a surface, and you can hit save, and we don't even need the point cloud anymore, so I'll just toggle it off. Okay, now it's time to create a surface. So we're going to do that in the Model menu. We're going to go to Extract to Surface. It's going to extract these points into a surface that'll be called ground. That's the default name, but if you have multiple surfaces, you can customize the name as well. I'll just pick on OK, and here it asks me to select all entities, and I'll just win-to-win all of the point nodes and hit Enter. Okay, and I can see down here there's a report that there are now 177 points in the surface. Once I've created my surface, the next step is I want to tin it and I want to inspect it. So I'm going to pick on the tin function here. Down in the command line it prompts me for which surface I want to tin for. Yes, I want ground, so I'll just hit Enter. And here I'll just show it because I just want to temporarily show it. So this gives me kind of a rainbow distribution of the elevations. I remember there were a couple of high points, and you can see that there are exceptions to the coloring. So that represents my digital terrain model, and that looks fairly good to me. Now, next what I'd like to do is let's quickly generate some contours on that surface. So first we're going to go into contour interval, and I'll just set the interval to 1 unit, and now I can pick on contour here. So again, down in the command line it asks me which surface are we dealing with. I want ground, so I'll hit Enter. Now it's offering just to show the contours, which is a good step to take as you're sampling your data, just to make sure that things look accurate. So that actually looks pretty good. We can see some high points here and here, which is what I saw in the scan. If we're happy with our contours, then what we'll want to do is make ourselves a new layer. Can set that to current. I'll give it a special line type so that it stands out from the other items in the drawing. And now let's draw some contours. Enter. And this time I'll hit D to draw the contours on the current layer. I'll say no to closing them all. There we go. Okay, so now we've got some contours. And so let's do a little bit of contour labeling now. So I got the label contours function right here. So right now it asks me what's the height on the ground that you'd like your contour labels to have. I think about 1.5 units is about right, judging by the fact that this is a 5x5 grid. Hit Enter there. It gives me the option of using either trimming or wipeouts to hide the part of the contour that's being labeled. I'll tell it I want to use wipeouts. Enter, and then all you have to do is just pick the locations where you want the contour labels to be, and it grabs the elevation right out of the contour and it creates the label. I'll hit Escape here. Now we've got wipeouts being shown right now, and so I'm just going to quickly turn them off by typing wipeout, and I pick the frames option, and I want the frames to be off. There we go. Frames are hidden. So now you've got some contours that you can turn into a final drawing. Finally, what I'd like to do is talk just a little bit about what you can do with a surface once you've created it. Now, we've created a surface, and we can certainly draw it in the drawing, but the surface itself is stored in memory right now, and if you want to keep it for future work sessions, you want to open up Surface Management and you want to write a QSB file. I'll call that aggregates. And so that way, later on, if you need to do some work with the surface, like for example, volume calculations, all you have to do is read that same QSB file and it'll load up the surface. And also, if you need to share the surface with other users, you have that option. One other important thing to make you aware of is sometimes your deliverable might just be a land XML file that you want to share with another user. So if you go to the Points menu, you'll find that there is an option to do a land XML export. I'll open that up. I'll call this one aggregates again. And here it gives me a list of all the surfaces in memory. And here I'll tell it I just want to export the ground surface in a land XML. And that you can save to another user. Finally, one other option is sometimes with machine control or other software they require the actual tin, and that's easy enough to do. Let me make another layer specifically for drawing the tin. Set that to current. So I'm going to go back to Model and to Tin. And this time I'll tell it, yes, I want to draw a tin on ground, but this time I want to D for draw that tin, and I'll draw it as a polyface. I'll go with all of my options. So here we've got a tin, and if I isolate just that layer by turning off the others, then that's the tin, and I could write this out as a block, or I could email this file to another user. It is drawn as a polyface. Sometimes you need to explode the polyface before a user can access it. Also, if you want to have a look at it in a more of a realistic display mode, then we can change our display mode to realistic. Or if you want to get a really detailed look at it, the MS Render tool allows you to spin your tin around and just make it, again, it gives you a more sophisticated way of inspecting your surface. There, I hope that's given you a good picture of all the things that you can do with point cloud data and with surfacing.